Welcome! In this series of short videos, we will look at topics for the PowerBasic Windows compiler. Today we will look again at running your Windows graphical applications on Linux Mint. This was an application running under Linux Mint at the end of the last video. The source code, originally written in the PowerBasic for Windows compiler, is mostly running okay. But there are a couple of problems. Both of these are in the terrain window. First of all, the small map is not displaying correctly. It doesn't fill the graphics control, and the yellow circle is not centered on the grid square you clicked upon. Secondly, the compass image is not centered on the 4 navigation buttons. Although this is merely cosmetic, it does make the screen look slightly odd. If we compare this to the same code running on a Windows computer, you can see that the small map's graphics control is correctly filled, and the yellow circle is also correctly positioned. The compass image is also centered with the 4 navigation buttons. So our task in today's video is to figure out how we can have the same source code running on both Windows and Linux Mint and display correctly in both. So let's have a look at the code to see where the problem might be coming from. So here we are on a Windows computer running the PowerBasic for Windows compiler. And we've loaded up the source code that we had at the end of the last video. There are 2 areas of this we need to look at. Firstly, we're going to look at the copying of the small map. There is a function called copy small map, which, as the name suggests, is the function that copies the small map from the first window, the primary window, to our terrain window. And if we look in here, we're passing a number of parameters to this function. Firstly, the handle of the dialog. This is the handle of the terrain dialog. Next is the handle to the graphics control that we wish to populate. We're also passing the handle of the payment dialog, and the next parameter is the handle of the graphics control we're copying from. And finally, we're passing an X and a Y parameter. This is where we're actually centering our graphic. This is the location the user has actually clicked on. So within this routine, there's a number of things happening. We're first of all determining the graphics location, X and Y coordinates, by multiplying the X and Y parameters we received by the box size. The box size gives us the size in pixels of the terrain box we wish to show. We're then attaching, using the graphics attach command, our small graphics map on the terrain window. So all graphics operations will be geared towards this graphics control. We're doing a clear to ensure there's nothing in that window, and we're getting the size of the window. Next, we're using an X and a Y offset. This is to work out, as you can tell, the size integer divided by 2 plus 20 pixels. All this is done to work out where we're copying to. So we're then using a graphics copy command to copy from the source window to our graphics attachment, this small window, using our beginning X and Y coordinates and our X and Y coordinates for the end we're going to grab. So that should populate the small graphics window. Next, we're drawing a circle round the center terrain. So having looked at this code, I think if there's a flaw, it's in the parameters we're using for this graphics copy command, because it's obviously not filling the graphics control. The circle, I think, is drawing correctly in the center of the graphics control, and this problem will disappear if we manage to copy the graphic successfully. Quite why the graphics is behaving differently in the Linux version as opposed to the Windows version is still a bit of a mystery. But we're going to try amending some of our parameters to see how this looks in Linux. Next, we have to look at the positioning of the graphic for the compass. So if we have a look where the window is actually drawn, this is the show dialog terrain info function. And further down here, we're positioning the compass on this graphics control. So in this section here is where the copy small map function is actually called. And then after we position all of the buttons, we're calling a load image file. The load image file function loads the PNG file, which is our terrain compass. And it returns the width and height of that graphic. And the handle to the bitmap that comes out of this function. And we're using graphic attach to ensure we're pointing towards the right control. We're doing a graphics copy command for the data held in the area specified by that bitmap handle, and then we're ending the bitmap. So again, this is a bit of a puzzler why it's not locating the graphic in the same position in both Windows and Linux. But again, we'll try amending this in the Linux version to see if we can get it to behave. So as we are planning and making some changes to our source code to cope with the strange graphical problems we're experiencing within Linux Mint, I don't want to have two sets of source code, one for Windows and one for Linux. If you do have two sets of source code, you have to maintain two separate sets of source code, and it's only a matter of time before they start to diverge radically. So I'm going to put some conditional code in that will execute at runtime and work out whether we're running under Windows or whether we're running under Wine. So first of all, we're going to create a global variable, which will be used to determine whether we're running under Windows or running under Wine. So here is a new global variable, running under Wine. If this is true, then we're currently running under Wine within Linux. If it's false, we're running under Windows. So we can test this at particular points during the code in order to display things correctly. So we first have to populate this new global variable. And this is a function that's going to perform this act. First of all, we're going to use a couple of Windows API calls. First of all, a call to the ntdll.dll. So we're setting two local variables, a handle to this DLL and another local variable called wine version. So we're first of all going to use the getModuleHandle API call to give us a handle to this DLL. Now that we have that, we can use it to use the getProcAddress API call, and this will attempt to get the wine version. If this returns a true, then we're running under Wine. If it returns false, then we are running under Windows. And we're going to call this function right at the beginning of our PB main function. So since we're running under Windows, let's run this in debug to see what value we'll get back. And there we're watching our two variables, the handle for the DLL and the handle for the wine version. So let's just step into this function and see what we get back. So we're getting a handle for the DLL. If we step forward to see if we get anything for the wine version, and it's returning 0, which is reasonable because we're running under Windows. So this should return the value false. So the code runs fine under Windows. Now let's look to see where we have to test this in our code. In our copy small map function, I suspected that the problem was somewhere around here. Somewhere where the values were being set for the graphics control. So I'm going to amend the X offset. Since the bitmap for the large map is being copied too far to the left, we're going to increase this value. We'll step it up from 20 to 30. But we don't want to do this for both the Windows and the Linux version. If we did this for the Windows version and ran our application now, and we pick our world map and process a turn, and then click on our non-player character, we'll see that it's too far to the left. So this would not work under Windows. The values for 20 would still be valid for Windows. So we can use our test to see whether this is Windows or Linux. So we're replacing this with a call on our new global variable. If it determines we are running under Wine, it will use the value 30. Otherwise, it will use the value 20. So if we run our application once more, it should display quite happily. And if we pick one of the characters, it's now correctly circled round the center of that character. So it's running fine in Windows. So this is the code amended for our graphics map. So let's now look at the positioning of the compass. If we go to where the terrain information is defined, and if we go down to the section that draws the compass control. So further down this code, in fact we can take out this commented out section of the code, we don't need that anymore. And down here where we're copying the small map, below this is the section that loads the compass PNG file and then attaches it. So we're going to put a bit of conditional code in here again to test our global variable. And we're going to move this control slightly to the right. So at the moment it's going to 418.285. Let's change that to 426. And this is only going to run if we're running under Wine. So if we compile that to make sure it compiles cleanly, and we now have a new executable. So let's run this just under Windows to make sure it doesn't interfere with the Windows application. And that looks fine. The Windows one is unaffected. And we haven't broken any of the existing code. So let's now take that source code and we'll put that into Linux. We'll recompile and try running it in there. And here we are now running under Linux. If we scroll down, we can see our conditional code sitting there quite happily to move the compass. So let's run the application, pick our world map, and when that loads, we will do a process turn so we can actually see the individual NPCs. And there we have on screen our user located at the center of the small map with the yellow circle around him. And also, the compass is now centered between all of the controls. So if we change the stepping to make it larger, and let's step a bit to the right, to the east, and the map is continuing to fill the small graphics control, and still displaying quite happily on the main terrain map. So let's try one more near the coast, and there it is centered on the small graphics map, and everything is still where it should be on its section of the screen. So in summary, what we've achieved today is we have fixed two problems when running our PowerBasic Windows source code under Linux Mint. In order to do this, we've created a special function to determine whether our application at runtime is running under Windows or running under Wine. This allows us to put conditional code to handle these two issues we had with the placing of data on graphics controls. So now our application will run exactly the same in Windows as it does in Linux. Hopefully you'll find these techniques and code useful in your own applications, but that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.